Good morning everyone. So in continuation again with the chapter number 2, we are going to see something more about the designing of components. So in last lecture we have seen something the designing components which were required in this designing components. So let us see in continuation with that again what are the main things we are going to say in this part. So the next we are going to see is the commercial of the shelf components. This is nothing but the commercial of the shelf products, that is nothing but the product which is designed by the own manufacturer. What are the commercial needs of it with respect to that ASCII processors and or the PLDs which we have seen in the last lectures. With compared to that, what these COTS are, we are going to see it today. So the commercial of the shelf product is one which is used as it is, as is. Okay, so the COTS components, that is nothing but itself, will be developed around a general purpose or a domain specific processors or an ASCIIs or PLDs. So as we have seen all the details about the general purpose processors, we have seen all the things about the domain specific processors, we have seen the ASCIIs processors, and also we have seen the PLDs, that is the programmable logic devices, in which the programmable logic devices was everything related to the gates. So with respect to all these domain specific general purpose or ASCIIs, PLDs, this COTS is being developed around these processors. Basically, the major advantage of this COTS is that they are readily available in the market. As the processor, as the chips as it is, this does not have to be developed any extraordinary. These COTS are readily available in the market, and as the chips are the chip, and it is developer can cut down his own her development time to the great extent. Means this chip can be developed according to his or her development, what it can be developed more into that chip. So accordingly the chip can be manufactured by its own design by the manufacturer. But the major drawback of using this COT is that the embedded design is that the manufacturer of the COT components may withdraw the product or may discontinue the product anytime. Means what? As the design of the manufacturer is something different, and suppose that manufacturing is not required in the market for the long time period, the manufacturer can discontinue that particular manufacturing of that COT chip. So this is the main disadvantage of this COT, and that rapid change in the technology is occurring each and every time. So as the rapid technology is increasing, as the designing of the manufacturer is increasing, as the demand of the customers is increasing, accordingly the COT or the products which are older as compared to that of the new designs may discontinue. This is only the major drawback for this COT. So let us see what are the advantages and disadvantages of COTS. So the advantages is that it is ready to use, as we have seen earlier. This COT is ready to use product and it is available in the market anytime, and it is easy to integrate. Easy to integrate is nothing but it can be easily integrated into that processor anytime or anywhere, and thus it is the advanced processor. It is used with respect to the general purpose PLDs, or it is adjustable to any of these processors. The time required to develop this COT is reduced. But the disadvantage is that no operational or manufacturing standard, that is all proprietary. Means what? There is no any standard. Means for example, I can tell you the 8085 or 8051, as I told you, all the manufacturer is having its own data sheet, right? There are some manufacturing standards, but this is not, this COTS are not having its own, or it is not having any operational or manufacturing standards. It is according to the own design. So the vendor or the manufacturer may discontinue the product of the particular COTS anytime. So this is the two major drawbacks of the COTS. Next to that we are going to see the sensors and actuators. So everyone knows there are different kinds of sensors we are using. For example, I can as for example is that for temperature there is a temperature sensor. For alcohol detection there is alcohol sensor. For air pressure there is a something different. For the moisturizer, to control to see the moisturizer content in the soil or anywhere in the air, that is another sensor. So likewise, according to the application, there are number of sensors designed. So what actually is a sensor? Sensor is nothing but it is used for taking the input. First thing what the sensor do, the sensor is going to take the input. It is used for taking the inputs. And after taking the input, what it is going to do, it is nothing but that sensor is going to work as a transducer. So everyone knows what you mean by transducer. Transducer is nothing but the kind of energy which is converted from one form to another form. For any measurement or for any control phase purpose, the sensors can be used. For example, if you consider, it is a temperature sensor. Next we are going to see the actuators. Now this actuator is nothing but a device which can be used as an output. As we have seen earlier, sensor is a device which can be used as an input, but actuator is a device which can be used as the output. So it is the transducer, or it again the actuator is also a transducer, but this transducer is maybe either mechanical or it may be the electrical, which converts the signals to the corresponding physical actions. For example, suppose as we have seen in earlier communication techniques also, if you want to consider one audio signal, if you want to consider one or you want to send one audio signal from one place to another, that is from transmitter to receiver. So as you are sending a sound, means what is the applicable device at the output? Obviously the sound you are going to listen, means the microphone is expected in return. So that is the physical connection between the sending and receiving. Similarly, if you want to transmit the video signals, now video means you need to see that video signals, is it not? So with respect to video means you can add the display, that is the LCDs, or you can add the LEDs at the big screens at the receiver side. So with respect to the input, what kind of input signals you are going to transmit, accordingly the output signal has to be taken. Okay, so likewise we are going to transmit the actuators at the receiver signals. For example, LED, right? Now LED is nothing but light emitting diode. So as this LED is a light emitting diode, this LED is having, or it is going to work in a PN junction diode, which also contains an anode and it contains an cathode. Okay, so let us see with respect to the diagram of this LED example. Now here you can see this is a figure of an anode. Okay, so this anode and this is the cathode, or vice versa, these 2 points can be connected. So for functioning, the anode is connected. Now this anode is connected to the positive end of the supply, that is the VCC. Now this VCC is connected with the resistor over here. Okay, and the another cathode is connected to the negative end of the power supply, that to the ground. So the maximum current flowing through the LED, so the current which is going to flow through the LED is limited by this resistor R, where this R is connected in series with this LED as shown in the figure. So here in the figure you can see this LED is connected in series with this LED, this resistor is connected in series with this LED, and this anode is connected to VCC and this is connected to the ground. So while interfacing that LED, it can be interfaced to either a microprocessor or it can be connected to the controller as well. Suppose the anode of the LED is connected to the port pin and the cathode is connected to the ground. Means if you consider this first option, so what can be done? In this approach, the port pin sources the current to the LED. Means if we are going to connect in that position, the LED is going to get the source current, and when it can be logic 1, that is nothing but it is going to be high. But suppose if you are going to connect the cathode pin to the port pin of the microcontroller or processor and the anode pin is connected to VCC, at that time the port of the port pin source the current of the LED, which is logic 1, and here the port pin sinks the current. Now the cathode is connected to the port pin. Port pin means which port pin? Any of the port pin which if you are going to use the microprocessor or microcontroller. Understood? So once the port pin is connected to the port, any of the cathode is connected to the port, the LED is going to turn on and the port pin is going to go 0, that is logic 0. So when the LED is turned on, it is going to go logic 0. If it is not connected to the port, it is going to turn as logic 1, that is high. So next we are going to see the communication interface. Now as we have seen so long that there is an transmitter, there is one receiver, there is one actuator, there is one sensors that has been connected as an input, that has been connected at the output, is it not? So far all these things which we have seen, if you have seen processor, right from the microprocessor, microcontroller, all the different kinds of processors, DSPs, PLDs and rest all things. So with respect to these things, there is a communication interface. Now we have seen this part earlier also. Communication interface means what exactly? Now suppose you want to communicate between a mobile and a laptop. For example, you want to connect or you want to interface a mobile and a laptop, or you want to communicate between these two products. What you can do? You are going to use a USB cable. Is it not? Unless and until using the USB cable, the port is not going to work. This is the first option. Second option is either you can connect these two devices with the help of the Wi-Fi. Okay. Either these two things can be connected with the help of the Bluetooth. Right. So either these things can be connected with the help of any application like ShareIt and rest all things. Now it is banned, but we used to connect all these things. Is it not? So there are number of examples where you can connect the interfaces, that is the communication interface. So for any embedded system you are going to use, the communication interface is broadly classified into the internal communications embedded systems, that is the communication between different components present on the system. Okay, so there are some common examples on the onboard interfaces. Means onboard interfaces is what are the types of what you can say components we are using, and each and every component should have the communication between each and every device. For example, suppose you have given an input to the sensor, the output you are taking at the load, means there should be the connection between the LED and the microphone at the output. Is it not? So likewise, each and every component in the chip, whatever you have been connected, should have the communication interface. So like you can, there are some common examples which can be used, that is I2C, integrated circuit. This is one example where you can get interfaced. Second one is the SPI, that is the serial peripheral interface. Third is the UART, that is the universal asynchronous receiver and transmitter. One wire interface, parallel interface. And now the examples of inter-integrated circuit. Basically these are the 4-5 common examples: integrated circuit, inter-integrated, serial peripheral, universal asynchronous, wire and parallel interface. So these are the main, but with respect to this I2 square, let us see what are the more classified I2C. So it, first of all, this is the synchronous, I2C is the synchronous. Okay. Now it is a bidirectional. This I2C can be used as a synchronous, means it can be used for the bidirectional communication. It can be used either for the half duplex communication as well, and either it can be used for the 2-wire serial interface bus also. Which is now, this I2C was basically developed by the Philips Semiconductors in the year 1980. So basically this comprises of 2 buses. First one is the serial clock and the second one is the serial data, that is SCL and SDA. So the SCL generates the synchronization clock pulses. What is the work done by this SCL? This SCL is nothing but going to generate the synchronization clock pulses, and this SDA is nothing but going to transmit the data serially across the devices. So if you are going to connect the LED and the microphone, or the audio or the sensor and the microphone, so with respect to that, the communication has to be sent one by bit, the clock pulses has to be transmitted and it has to be received accordingly. So this I2C is shared bus system to which many devices can be connected. With help of this inter-integrated circuit, there are number of buses which can be connected to this. So the device connected by this I2C can be either master or slave. Now as we know, what do you mean by master? Master is where only one single computer will be working, and rest all the computers which are connected to the main processor is nothing but going to work as a slave. Is it not? So this I2C can be a master or it can work as a slave as well. So the master device is responsible for controlling the communication by initiating or terminating the data transfer. Now if suppose this I2C is going to work as a master device or the master, while it is working as a master device, it is responsible for controlling the communication or by initiating or by terminating the data transfer. Now obviously I am working as a master means I have the control of all the other PCs either to initiate the data. I should first see which computer should send the data to me first. I should look upon all these things, and either I can terminate. Terminate means if I suppose I want to stop the data from this computer, I can terminate the data as well. So with respect to this, we can see what the integrated circuit is and how it is communicated with different components. So here you can see how the I2C bus interfacing is done. So here you can see this is the master where the microprocessor or the microcontroller is used. So with this microcontroller, it is having two pins. As I told you earlier, this is the SDA, that is the serial data transmission, and the second one is the SCL, that is the serial clock. With respect to this, there are the two buses. One is SCL, one is SDA. This SCL is connected to SCL, SDA is connected to SDA. With respect to this, the data is connected to slave 1, the data is transmitted to slave 2. So this slave 1 is nothing but, for example, suppose it is a serial EPROM and this is the I2C device. So this clock is being transmitted as well as the serial data is being transmitted. So likewise from the master to this slave to this, with the help of these two buses, the data can be transmitted or it is received. So the device acting as a slave, where they are going to see that the device is going to work as a slave, the slave has to wait unless and until the master is going to respond to this slave. The slave is not going to initiate on its own. So this is the interface between the I2C bus interfacing. And the next we are going to see what are the external peripherals for the communication purposes. So there are used for the external communication of the embedded system, that is the communication of different components present on the system with external or peripheral components. For example, for external connection, you have some common examples. First one you can see is the RS-232C or RS-485. As I told you, universal serial bus can be USB, can be used. IEEE 1394, that is the firewire you can use. Infrared device you can use. As I told you, Bluetooth can be used, Wi-Fi can be used, Zigbee can be used, general packet radio receiver, that is the GPRS. So as I told you the example just now, where you want to communicate from the mobile to the laptop. So these are the some common interfaces where you can connect or where you can communicate between the external devices. Now where you have seen these